All right, welcome back, guys. We're going to finish off Chapter 5. We really have 2 sections left in Chapter 5, but what we're going to do is we're going to break it up into 3 parts. So 5.4 is solving rational equations. So we're going to have an equal sign in between because an equation implies that we have equals. And then we also have in 5.5, which is solving rational inequalities. That'll be greater than or less than signs in between. And then what we'll do is we'll group together the word problems for both equations and inequalities together in a final section that brings them together. So we'll just work on just the equations to start. The first one here in 5.4 will be similar to one that you saw in grade 11 when you solved rational equations there. So we're going to be taking that idea and extending it to the inequalities. So we know that when we solve rational equations, we have a few steps up at the top. We bring all the values to one side if we can. That way either the left side or right side will be equal to 0. Sometimes we can cross multiply if possible. So if you have a fraction that allows you to multiply both sides by whatever the denominator is, you can do that. Then we're going to factor the side of the equation that has our new polynomial, and we'll eliminate any nonsensical answers. So typically in word problems, if you get something like a negative time, for example, that would be one that we would eliminate because it's outside the context of our problem. It's before our problem started. But when we're dealing with rational functions, you might have remembered from grade 11, we do have to take into account any restrictions that occur, and we also have to eliminate any answers that could be restrictions. So for example, if I found out the answer was x is equal to 2, however, x is equal to 2 is one of the restrictions that we cannot have, that would have to be eliminated from my final answers as well. So what we're going to do is we're going to look at a relatively easier equation that we'll start with. So the left side over here, we can't simplify it anymore. We know that one of our restrictions in this case is that x cannot be 3, because when x is 3, the denominator will be equal to 0, and whenever we have the denominator 0, that is an undefined function. So we know that we can set that restriction as x cannot equal 3, and then we solve this. So if I kind of just zoom in on this equation here a bit, one thing that we do know, in order for a fraction to be equal to 0, I do know that the top has to be equal to 0. Because a fraction is only equal to 0 if the top is equal to 0. So it doesn't matter what's on the bottom, I just need the top to equal 0. But the idea behind it is, if you think about math, what we're going to be doing, if we want to isolate, what we technically do is we multiply both sides by the denominator, x minus 3 over here, and x minus 3 over here. So on the right side, if we're multiplying 0 times x minus 3, we end up with just 0, because 0 would be distributed inside that bracket, but 0 times anything is 0. On the right side of, or left side of the equation, we have that x minus 3 that would end up canceling out on both sides. So essentially we get what I said earlier, which was just the top of the equation, x minus 2 equal to 0. Now in order to isolate for x, what I'm going to have to do is bring 2 over to the other side. It's adding 2 to both sides, which essentially gives us our final equation, which is x is equal to 2. And that's the final answer for this one. And we'll continue on to the next one. So what we have over here is a polynomial, a rational function with a polynomial on top and a polynomial on the bottom. So before we do anything, what we want to do is state our restrictions, where the bottoms cannot be equal to 0. So when I look at this, I see that the fraction that we have on the left, we know that x cannot be equal to negative 3. Fraction that's on the right, x cannot be equal to negative 7. So I'm going to state those restrictions before I do anything. Say x cannot be negative 3. It can also not be negative 7. Then from there, what we're going to do is we're going to try to solve this. So what I can do is, I see I have that polynomial on the left. I have a factor of x minus 3 on the top and bottom, so I can cancel them out, which leaves me with x minus 2 all over x plus 7. And then kind of the same idea as the first question that we looked at. We know that the top is what needs to be equal to 0. Basically what we can do is multiply the left and right side by x plus 7, and just what that's going to happen is the x plus 7 is going to be gone. Leaves me with x minus 2. And I bring 2 over to the other side, and we end up with x is equal to 2. So similar to the first question, however, we did have one factor that we can cancel out in that case. Keep rolling along here. This one we have a fraction on both sides. So what we can do is, well, I can bring all the values to one side, so I can take this whole fraction over here and bring it to the left side and then try to get common denominators. But a faster way of doing that would be to cross multiply. Top times the bottom. That would be 2 times x minus 1 is equal to top times the bottom of the opposite sides. 5 times x plus 3. Well, I'm just going to write 5 times x plus 3. Then we solve this like a linear equation, which we solved back in grade 9. We distribute the 2 and the 5 inside the brackets, leaving with 2x minus 2. On the right side, distribute 5 inside, 5x plus 15. Get all my like terms together so I can bring my 5x to the left side. 15's over here on the right already. 2's going to join it. It's going to become plus 2 because essentially what's happening, this term over here came, 5x on this side came on that side. Right, really what we're doing is we're adding and subtracting the opposite. And then all we're going to do is add our like terms together. So on the left side I get negative 3x. On the right side we get 17. And we divide both sides by whatever's with the unknown. And we get x is equal to 17 over negative 3. Keeping in mind in this case we'd have to state our restrictions as well. So that's from the very beginning of our equation. We would say, well, x cannot be equal to negative 3 and 1. That's not my answer that I have, so we're okay with the answer that we have based on the restrictions that we had. Keep rolling along here. Now in this case we have a couple of options, just like the first one that we saw. We could take this one and say, well, let's bring 3 over. So I have all of that fraction plus 3. Right, it would end up looking something like this. It's not the fastest way to do it because, we'll show you in a second. Because then I would have plus 3 is equal to 0. And then I need to incorporate this 3 into that fraction on the left, so I'd need to have a denominator of 5x minus 1, which means I'd have to have 5x minus 1 on the top and the bottom of that 3 in order to get common denominators. A little bit of a faster way to work with that one would be to take our equation and just say, well, let's take the left side, multiply it by 5x minus 1 in order to get rid of that denominator, and multiply the right side by 5x minus 1. That was a trick that we learned back in grade 9 about how do we get rid of fractions. Well, just multiply both sides by whatever the denominator is, because that will cancel out over here. That'll leave us with 2x plus 3 and 4x minus 1 on the left side. On the right side, when I distribute 3 into that bracket, I'm going to have 15x minus 3. Now what I'm going to do is I'm going to try to bring all the values to one side, but before I do that I'm going to have to expand this binomial that we have over here on the left side. So when I expand that one, we're going to have 8x squared distribute through negative 2x plus 12x minus 3. That's just using FOIL on that bracket. We still have 15x minus 3. And what I'm going to do is bring all the values to one side. So I have 8x squared. We have negative 2x and positive 12, which is positive 10x. I'm going to bring over this 15 because it has an x, 15x. Bring it over to the left side. So I'm going to join it as well. It's going to be minus 15x. Then I have the minus 3 from the left side, or subtract 3. And then what's going to happen is I'm going to bring that 3 over from the right side. So this one over here, it's going to come over. It's going to be plus 3. All that's equal to 0. We can simplify from what we have. I have 8x squared minus 5x is equal to 0. So we're almost there. I need to solve what we have over here. I have a quadratic on the left side. So I know in order to solve a quadratic, I can either use quadratic formula or to factor. Probably easiest to factor because we have a common factor in this case. And I can solve by setting my values equal to 0. X is equal to 0, and this one over here, x is equal to 5 over 8. So we have these answers. I want to see, are they part of the restrictions that we have? So when I go back up to the original question that we have up here, I'm going to figure out, do we have any restrictions? Well, the denominators can't be zeros. Those are the only restrictions. So in this case, the bottom cannot be equal to 0. This here cannot be equal to 0. And it would be 0 if x was equal to 1 over 5. So I'm going to write that in my restrictions over here. X cannot be 1 over 5. And I see that 1 over 5 is not one of the answers that we have down at the bottom. So we're okay with both of these values being my solutions to that rational equation. So keep rolling along. 2 more to look at here. Same idea here. This one's a little bit different because it already is equal to 0. But what I can do is state my restrictions right away. Or I can do it after, doesn't matter. But x cannot be equal to negative 3 over 2. So if I get negative 3 over 2 as one of my answers, well, we won't be able to do anything with that. So what we're going to do is bring all the values one side, make it equal to 0. That's already the case. Factor both sides. So if I look at what we've got here, I have a trinomial on the top and a binomial on the bottom. I won't be able to break up that binomial. I'm going to try to factor this top one. So if you remember factoring, how do you deal with trinomials? There's a few different ways, but one that we learned was that if I look for a product of A and C, which is negative 60, and a sum for the number that's in the middle, 7. So when I go through the possibilities of numbers that we have 1 and negative 60, 2 and negative 30, and you can list them all out, 3 and negative 4 and negative 15, 5 and negative 12, and I see that 5 and negative 12 add for negative 7. I'm looking for positive 7, so it must be the opposites of those. It must be negative 5 and positive 12. So negative 5 and positive 12 are two numbers that multiply for negative 60. Negative 5 and positive 12 are two numbers that add for 7. So what I'm going to do is I'm going to break up that middle number into those two. So I'm going to erase what we got here. We found our two numbers. And I'm going to factor the top. So remember, when we factor the top, what we do is we break up that middle number. I'm going to put the 12 first, because 12 I like goes with 4 really well. Minus 5x minus 15. And we're going to factor that one. So remember, when we factor these, we factor them by grouping. We group the first two, group the last two. First two I can take out 4x. If I do that, I'm left with x plus 3. Second ones I can take out negative 5. If I do that, I'm left with x plus 3, and the brackets should match, which is x plus 3 and 4x minus 5. That's just the numerator, remember that. We have our denominator as being 2x plus 3 is equal to 0. From here now I factored the left. But this is like the ones that we saw before. We have a fraction that's equal to 0, so I know that it's just going to be equal to the top part. Because a fraction is only equal to 0 if the numerator is equal to 0. You can think of that, or you can say, well, I'm going to multiply both sides by 2x plus 3. What's going to happen is, it's just going to be the top, because these will end up canceling out. It's just going to be the top is equal to 0. Same idea. Regardless of how you think about it, doesn't matter. We end up with just the numerator equal to 0. So I'm going to put that down below here. We have x plus 3. We have 4x minus 5 is equal to 0, and we're going to solve it. X is equal to negative 3, and we have x is equal to 5 over 4. We look at our restriction, and we see that our restriction was negative 3 over 2. That's not our answer, so we're okay with both these ones being our solution. So a few different ways you can think about that one, but same idea. You should get down to negative 3 and negative 4.5, just using our algebra skills. Last one that we have over here is a little bit different. This one has 3 fractions, an addition on the left side of 2 fractions and one on the right side. What we need to do first is identify if there are any restrictions. So we just have 2 on the bottom over here, so no value of x will make that fraction on the very far left undefined. The one in the middle, an x value of 5, would make it undefined, so I would write x cannot be equal to 5. And then we have 2x over here on the right side, so I know that an x value of 0 would make that undefined because 2 times 0 is 0. And those are our restrictions. X cannot be 5, x cannot be 0. Then what we're going to do is we're going to solve this. So in order to solve, what we're going to do, we have a few options, but one of the most easiest ones would be to combine these two fractions on the left into a single fraction by getting common denominators. And if we get common denominators, we'll have to get the numerators to be multiples of those. And then once I have that one fraction on the left side, I'll have a fraction on the left, one of them on the right, and we can cross multiply. So that being said, in order to get a common denominator, what I can do is multiply those two denominators together. 2 times x minus 5 is 2x minus 5. For our numerator, well, if I have 2x minus 5 as my denominator, well, I need to multiply this side by x minus 5, and I need to multiply the top by x minus 5. So we'll have x minus 5 times 1, which is just x minus 5. Same goes for the middle fraction. It needs a factor of 2, so I'm going to multiply that by 2. Bottom and top by 2. So 3 times 2 is 6. We have plus 6. And that's what our fraction will end up looking like. So that being said, on top I have x minus 5 plus 6. I can add those two, minus 5 and plus 6 together to get positive 1. So I'm going to add those ones together. Over on the right side, what we have is 7 over 2x. And then all we're going to do, I have a fraction on the left side, fraction on the right side, we can cross multiply. So remember, cross multiply, you take the bottom times the top. 2x times x plus 1, which is just 2x, x plus 1. Then we multiply 7 times the bottom. So 7 times 2 times x minus 5. So 7 times 2 is 14. Times x minus 5. And we're going to expand these through. So when I expand, we're going to get 2x squared plus 2x is equal to 14x minus 60. We're going to get all of our like terms together, so I'm going to bring 14x over and negative 60x over. Really what we're doing is we're doing the opposite operations. We're subtracting by 14x and we're adding 60. I have a pair of like terms in the middle here. We can add them together, and that's just going to leave me with a quadratic equal to 0. And we've solved ones like this back in grade 10. All we need to do is either factor to use quadratic formula. In this case, I see that they all have a factor of 2. So if I factor out 2, and we divide each of these by 2, oops. And we try to factor what we have inside this bracket. Because 2 is not going to give us a value for x to solve this. We have that trinomial in the middle. However, we can't factor that. There are no two numbers that multiply together for 30 and add for negative 6. So what we're going to have to do is use quadratic formula. So if you remember the quadratic formula was negative b plus or minus the square root of b squared minus 4ac all over 2a. So, negative b, negative, we have a, b, and c. We have negative 6, which is positive 6, plus or minus the square root of b squared, so that's negative 6 squared, which is positive 36, minus 4 times a, which is 1, times c, which is 30. So 4 times 1 times 30 is 120. All of that over 2a, so 2 times 1. Now, if I look at what we've got here, I notice that our discriminant part underneath the square root is going to be negative. 36 take away 120 is going to be a negative number. So that would mean that there are no real solutions for this question. There are no x values that will make that equation equal. So I'm just going to write that down. No solution. There are no x values that make this true. So that's how we solve these equations. It doesn't matter whether you use cross multiplying, whether you're combining fractions. We have different algebra roots in order to get our solutions. But that's how we do that for this one here.